Okay, let's start by talking about what you wrote to compare these two functions. Both functions are powers of 8, so they're degree 8 polynomials. Um, and knowing that they're even degreed polynomials. So we've got the similar end behavior on both sides. But the power function x to the power of 8 looks like a really wide, wide near the origin but skinny parabola, very narrow parabola. And this one is a transformed version of that. It's the same original base function, but what we should have used is this function has been compressed. Now 4 over 5 is a number less than 1. So all of the y's have been compressed vertically. They should be, if you graph them in Desmos, you're going to see that they're a little bit squished towards the x-axis because of that 4 over 5 number being less than 1. Then the only other change is that that original x to the power of 8 function has been shifted to the right 3 and down 5. Those are some words that you could have used to compare those two functions. Next is what we're going to do is we're going to talk in general about the transformations, and then I'm going to graph one particular function. Okay, so on this slide, feel free to pause this and copy this down into your notes. This is the general form for any polynomial function. Notice here, I'll circle it, or put a square around it, rectangle. This is the general form for any transform power function. Okay, so notice that we've got a double set of brackets here. We've got something to the power of n. This a, notice it's right here. It corresponds to a vertical stretch or a compression. So it's either the function has been squished towards the x-axis if it's compressed, or pulled away from the x-axis if it's been stretched. And that has to deal with whether a is less than 0 for a compression or less than 1 for a compression and greater than 1 for a stretch. We've got k being inside the power of the function, so it's inside this calculation, and therefore k is a horizontal stretch or compression, and it is the value of that stretch or compression is a reciprocal. It's the opposite of what we think, and I'll show you how we deal with that. And we've got a value of d, which is a shift left or right, and we've got a value of c, which is a shift up or down. And these numbers correspond exactly to what our grade 11 transformations work did for all of our different types of functions. Okay, so graphing these are going to be very similar to the way we graph these in grade 11. Here, let's do one. Here's an example. Say I got to sketch this graph. Y equals -1/2, and then in brackets I got a 4, and then look at in brackets again I've got an x minus 2, all cubed, and then I got to add 1. Okay, so here are my steps. I go through a couple different steps. First one is I'm going to list what transformations are needed, and even before that I'm going to say, look, this is a cubic function because of that power right there. So we're comparing this when we talk about transformations to x to the power of 3. And we're going to go back and we're going to use words from that last slide to compare them. Okay, so when I see all this, I look at some numbers. The first number I look at is this one here, and I've got my a being -1/2. And what this tells us is since 1/2 is less than 1, our graph compared to that base graph over here is vertically compressed. It's going to be pushed towards the x-axis compared to that one, so a little wider. Then the negative, okay, so the negative means, like we noticed before, like we've already talked about, that it should be upside down. Okay, so our end behaviors will be the opposite directions as this one. So it's a reflection, it's reflected. So we knew that already. Okay, so that's dealing with the a. Now this number here, this 4, since it's inside the calculation, and what I mean by that is there's the cubic out there, that's the calculation, that 4 is inside that calculation, and it's being multiplied around this x. Okay, so the argument of the function. So the 4 is the k. So we got 4, and therefore we've got a horizontal. Anything inside that calculation is horizontal, and since it's multiplying, it's a stretch or a compression, just like this one, but it's the reverse. Okay, so we say this one, since 4 is bigger than 1, 4 is also a compression, and we say it's compressed by a factor of 1 over 4, and that's always the case. Okay, so it's always the k is we're going to always multiply the x's, and I'll tell you what I mean by that in a minute, by 1 over whatever that number happens to be. Alright, let's talk about this 2 in here. So the 2, like I talked about in the last slide, is, I think we've got it labeled as a C on this. Oh, it's a D. Okay, so the D is a 2, and that means when it's x, it's always in general x minus whatever the D happens to be. So the D is a 2, and this means it's a shift right by 2. So the whole thing's going to go right horizontally by 2. And our last number here being a 1, this is our C value, that's a 1, and it's outside that calculation. This corresponds to a shift upwards by 1, and it's up because it's positive. Okay, so those are all the words we're going to use, and these are the transformations. Here's how we're going to set this up. How we set all of them up is I make a table of values. And I make a table of values based on the original function. Our original function was that ugly thing, but the base function it's being compared to is x cubed. So what I do is come up with some key points for x cubed. Let's just do some easy x's, and let's use the same x's for all of our power functions. So let's go, if I put a negative 2 in there, I get negative 2 cubed, that's a negative 8. And if I put a negative 1 in there, I get negative 1. I put 0, I get 1, I get 8. So these are some key points. If I plot them, I get the values for x cubed. Now, what we do is we modify these points based on the transformations we've already discussed. So what we do is we do all of the multiplying ones first, and it has everything to do with whether it's vertically affected or horizontally affected. So I'm going to deal with my A first. A, we said, was compressed, and it's a reflection, and it's a vertical. I should add that. This is a vertical compression because it's outside that calculation, being that cubic part. So this is vertical, which means it affects the vertical values, which are the y values. So what we do is we add a column, and since the a value is negative a half, we multiply by negative a half. We will always multiply by the a value. So when I multiply these by negative a half, I get positive 4. I get a half. I get 0. I get a half. I get negative a half, and I get negative 4. Okay. So that takes care of doing the stretch and the reflection. Notice I've got the reverse of the signs. Okay, so I've taken care of my a value and how it changes my graph. Next, I'm going to do my horizontal compression. Now the horizontal compression is we always multiply horizontally by 1 over whatever the k happens to be. And that's why I wrote a fourth here. Okay, so I'm going to go back here. Now a horizontal compression affects the horizontal values, which are the x values. So I'm going to multiply all these by a quarter. So when I multiply by a quarter, I get negative a half. Multiply by a quarter, I get negative a quarter. Multiply by a quarter, I get 0, quarter, and a half. Okay, next. Okay, so we've taken care of all of our multiplying around that. Now we'll do our shifts. The last thing we do is our shifts. So we can do them in any order. I could shift everything up 1, and I might do them on the, it doesn't matter which one you do first. Let's do the vertical shift first. So we're going to add 1 to all of our y values, because that brings all the y's up 1, and it's vertical. So we add it to the vertical side. So I'm going to add 1 to all of these. So that's 5. That's 1.5. That's 1. That's half. And negative 3. Okay, so that takes care of shifting all those points up 1. Now we'll move all those points to the right 2, which means we're going to add 2, because it's right, we're going to add 2 to all of the x's, because we're going to go to the right 2. So we'll add 2 to all the x's. So if I add 2 here, I'm at 1.5. If I add 2 here, I'm at 1 3/4. And if I add 2, I get 2. If I add 2, I'm at 2 1/4 and 2.5. Okay, so that takes care of all of our transformations. What's the last step is to go and plot these new points. The outside columns are now our new points. Here's what I'm going to leave for you. I want you to now notice that this was the 0, 0. This is where it kind of, x cubed comes and scoots and then goes back up. That point is now 2, 1. So it's over 2, up 1. And I want you to plot that and bring this into class. And then these are all the points. So you take this being your new x, this being your new y. You do it all the way down. The outside columns are the new points to graph. Plot those, bring this into class to have it checked out. There you go. That's how we graph the transformations.